Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video, Quadratic Functions, is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In this video, we will be reviewing quadratic equations, introducing quadratic functions, changing quadratic functions into standard form, finding the zeros in quadratic functions, and graphing quadratic functions. In previous lessons, we learned how to solve a quadratic equation that takes the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not equal to 0. Equations like this can be solved for x by factoring, completing the square, or by using the quadratic formula. For example, the quadratic equation x squared plus 5x plus 6 equals 0. The left side of the equation can be factored into the quantity of x plus 3 times the quantity of x plus 2. The zero product property tells us that if two variables multiply times each other equals 0, then one or the other must be equal to 0. Therefore, x plus 3 must equal 0, or x plus 2 must equal 0. Solving for both, either x equals -3 or x equals -2. A quadratic function is similar to a quadratic equation, but is expressed as a second-degree polynomial function of the form f of x is equal to ax squared plus bx plus c, where a, b, and c are all rational numbers and a is not equal to 0. This function can, in all cases, be graphed in the shape of a parabola with a vertex and axis of symmetry. When a is greater than 0, the parabola will be concave up, meaning it has a vertex or minimum at the bottom and opens up. When a is less than 0, the vertex will be at the graph's maximum and be concave down. The vertex of a quadratic function may be determined in two ways. First, if the function is in the form ax squared plus bx plus c, then the vertex is the point -b over 2a, f of -b over 2a. For example, the function x squared minus 2x minus 3. In this equation, a is equal to 1, b is -2, and c is -3. B over 2a would then be -2 over 2 times 1, which simplifies to 1. F of 1 is then 1 squared minus 2 times 1 minus 3, which equals -4. The vertex is then at 1, -4. The second method is to put the quadratic function into standard form. This form will be f of x is equal to a times x minus h quantity squared plus k. In this form, h and k will be rational numbers, and together will be the vertex. To arrive at this form, we take the original function and complete the square. Take the x coefficient, divide it by 2, add the square of this number as a new third term. Then, to maintain equality, we subtract the same number at the end. The first three terms can now be partitioned within parentheses and complete the subtraction operation to get -4. The trinomial in the parentheses can now be expressed as x minus 1 quantity squared. The vertex can now be easily seen as 1, -4. When graphing a quadratic function, the zeros represent all ordered pairs where either x or y is 0. This, by definition, will be the x and y intercepts of the function. The y-intercept is easily found by setting x equal to 0. For example, take our quadratic function from earlier and find f of 0. Replace the x terms with 0, and we're left with -3, giving us the point 0, -3. To find the x-intercepts, we set f of x equal to 0. This puts the function into a quadratic equation, which can now be solved as we have learned before. In this case, the left side can be factored into x minus 3 and x plus 1. If x minus 3 equals 0, then x equals 3. If x plus 1 equals 0, then x equals -1. Therefore, the two x-intercepts are 3, 0, and -1, 0. To graph this quadratic function, we can simply use the 4 points we have already calculated. The vertex is 1, negative 4. The y-intercept is 0, 3. The x-intercepts are 3, 0, and negative 1, 0. We know this graph will be in the form of a parabola, and since the x squared term is positive, the parabola will be concave up with the minimum at the vertex. We can now sketch the graph. If an additional point is needed to sketch more precisely, we know that the graph is symmetric across x equals 1, which means f of 2 will give us the same value as f of 0, or negative 3. As another example, let's graph f of x is equal to negative x squared plus 6x minus 4. The first thing we notice is the negative x squared, meaning this graph will be concave down. The simplest point to plot will be the y-intercept. F of 0 will be negative 4. If we use negative b over 2a, we get negative 6 over 2 times negative 1, which simplifies to 3. F of 3 is negative 3 squared plus 6 times 3 minus 4 equals 5. The vertex is then 3, 5. Next, for the x-intercepts, we set negative x squared plus 6x minus 4 equal to 0. For this, we can use the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. In this equation, a will be negative 1, b will be 6, and c will be negative 4. Fill in the equation and simplify. Inside the radical, 6 squared is 36, and negative 4 times negative 1 times negative 4 is negative 16. 36 minus 16 is 20. Since 20 is 4 times 5, the square root of 20 simplifies as the square root of 4 times the square root of 5, or 2 times the square root of 5. The two terms in the numerator and the denominator can all be divided by negative 2 to give us the final answer of 3 plus or minus the square root of 5, which is approximately equal to 0.76 and 5.24. Here is a sketch of the graph. It may be difficult to accurately establish these x-intercept points on a reasonably sized Cartesian graph. For increased accuracy, one may also plot f of 6. Since the parabola is symmetric across the axis of symmetry, which is x equals 3, and f of 0 equals negative 4, f of 6 will also equal negative 4. As another example, let's graph f of x is equal to x squared plus 4x plus 6. As before, the y-intercept is found by solving f of 0, which is 6, giving us the point 0, 6. We'll find the vertex using the standard form. When f of x is equal to a times the quantity of x minus h squared plus k, in this form, h represents the horizontal shift, k is the vertical shift, and the point hk is the vertex. The x coefficient is 4. Divide it by 2 and square it to get 4. Add 4 after the x term, then subtract 4 at the end to maintain equality. Put the first 3 terms in parentheses. 6 minus 4 is 2. The trinomial in the parentheses factors into x plus 2 quantity squared. So the vertex is negative 2, positive 2, and the axis of symmetry is at x equals negative 2. We can use the axis to determine another point. If f of 0 is 6, then f of negative 4 must also be 6, giving us the point negative 4 is 6. Notice that the vertex is above the x-axis, and a positive x squared coefficient implies concave up. This function should then not have any x-intercepts. To prove this, we do not have to solve for f of x is equal to 0. We can just look at the discriminant of the quadratic equation, which is b squared minus 4 times a times c. This will be 4 squared minus 4 times 1 times 6, or 16 minus 24, which is negative 8. A negative number discriminant means there are no real number solutions for f of x equals to 0, and thus no x-intercepts. So we'll just sketch the graph with what we have. As another example, let's graph 2x squared plus 4x minus 3. Negative b over 2a will be negative 4 over 2 times 2, or negative 1. F of negative 1 equals 2 times negative 1 squared plus 4 times negative 1 minus 3, which is equal to -5. The vertex will then be -1, -5, which will be a minimum, and the graph will be concave up from there. F of 0 is -3, therefore y-intercept is -3. The axis of symmetry will be x equals -1, so f of -2 is also -3. Again, we find the x-intercepts by setting 2x squared plus 4x minus 3 equal to 0. We'll complete the square. Divide all terms by 2 and add 3/2 to both sides. Half of 2 is 1, and 1 squared is 1, so add 1 to both sides. The trinomial factors into x plus 1 quantity squared, and that equals 5/2. Square root both sides, subtract the 1, then rationalize the denominator to get -1 plus or minus the square root of 10/2. Combine with the common denominator to get x equals -2 plus or minus the square root of 10/2, which is approximately 0.58 and -2.58. From here, we can sketch the graph. A ball is thrown with an initial velocity of 24 feet per second from a height of 8 feet above the ground. The ball's height with respect to time is given by the following equation. H of t equals -4.9 t squared plus 24t plus 8. How long does it take for the ball to reach its maximum height, and what is that height? Any object whose movement is affected by gravity will follow a parabolic path. This question can then be solved by understanding the vertex of the parabola described by the equation. Use the vertex equation -b/2a with a equal to -4.9 and b equal to 24. -24/2 times -4.9 equals 120/49. This gives us the answer to the first question, approximately 2.45 seconds to reach maximum height. To find that height, we take h of 2.45, which equals -4.9 times 2.45 squared, plus 24 times 2.45 plus 8. Take the square to get 6.0025, and 24 times 2.45 equals 58.8. Multiply to get -29.41 plus 58.8 plus 8, or 37.39 feet. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.